Hello everyone, welcome back to part 5 of this training series, and in this session we will be discussing how to configure EBGP on Nokia routing devices. In the last session we've already demonstrated to you how to configure IBGP, so the internal BGP peering session between routers in the same autonomous system number. So if we were to verify, you will see that on R3 we will be having, if I run show router BGP summary, you can see that we have two peering sessions to R1 and R2. These are IBGP peering session. R4 and R5 also established IBGP peering session. Show router BGP summary. You will see that we have a peering session between R1 and R4. So now we need to also implement the external BGP peering. This is peering between nodes in different autonomous systems. For example, we have R3. R3 is in a 65,000. We need to establish an EBGP session with R4 in a 65002 and also an EBGP peering session to R6 in a 65001. We also have peering session between R6 and R7, R7 and R8, and also R5 and R8. So this is what we'll be doing in this session, just to help you understand how to configure EBGP peering session on Nokia routing devices. If you haven't watched the previous session, part 1, part 2, part 3, and part 4, the last session where we discussed about IBGP peering session, kindly check out the previous session. They will help you to understand how to implement the basic configurations on Nokia routing devices. So for EBGP sessions, again, I've mentioned that this is peering between nodes in different autonomous system number. Remember, we need to ensure that we have communication between nodes in different ASS. For us to be able to send traffic from a 65,000 to a 65004, we need to ensure that there is exchange of routes between these autonomous system numbers. And when we are using BGP, then we need to establish EBGP peering session for the external peering between different autonomous system numbers. So this is the focus of this session. For EBGP sessions, starting with R3. On R3, we know that we need to establish two EBGP sessions, one to R6, which is in a 65001, and another one to R4, which is in a 65002. Almost similar configuration. Again, we also need to create a group. So we are creating a group for each autonomous system number just to make it easy to identify. So we have a group EBGP A65001. This is for the peering session towards R6. And then we also configure the local AS, we configure the peer AS. So you need to pay attention when you are specifying the local AS and the remote AS. You need to ensure that they are the correct AS numbers. We also configure the family. So in this setup, we are only configuring the IPv4 peering sessions. After you've done this parameter configuration, you also need to specify the neighbors. Remember, in this setup, we are manually specifying the EBGP neighbors. So we run the command neighbor 200.200.200.1. And then for easy identification of these sessions, we use the description. So we configure description R6, which means this is appearing between R3 and R6. So with the group, when we start using BGP path attributes to control traffic, it will be very easy because we've configured the groups. So it's very easy to apply the policies on these groups. Next, we create another group. This is EBGP A65002. This is for the peering between R3 and R4, which is in A65002. So we specify the family, we configure the local AS, the peer AS, and then we are using the point-to-point IP. So for EBGP, many times we use the point-to-point IP addresses. If you are to use the loopback interfaces, you will need to do some other configurations for you to be able to achieve that, to ensure that we have sessions established between the two nodes in different autonomous system numbers. So on R4, we need to do the same. R4 has to establish an EBGP session with R3. So this is also very straightforward. We are creating an EBGP group A65,000. Family IPv4, we specify the local AS, this is the correct AS, And then we have the peer AS, we are configuring the local address, we have the neighbor. So we need to use the point-to-point IP configured on R3. This is 100.100.100.0. On R5, we also need to establish an EBGP peering session to R8. So these are the parameters. On R5, we haven't configured BGP, so we need to configure the autonomous system, which is 65002. And then we create the group EBGP as 65004 and configure the local AS, peer AS, and all the other parameters, and give the peer a description, which is R8. On R6, we need to do the same. On R6, we are establishing a BGP peering session, one to R3 and another one to R7. R3 is in as 65,000. R4 or R7 is in AS 65003. And then R7, we also need to establish two BGP peering sessions. So again, if you don't understand any of these commands, just leave a comment in the comment section, and we will help to explain to you so that you can understand each and every command that we are using for these lab setups. Finally, on R8, we need to configure these commands. We are establishing two sessions. We need a session to R5 and another session to R7. One thing to pay attention to, the AS numbers that you are configuring, the point-to-point IP address that you are using for EBGP session should be the correct one. It will help you save on time that you could have spent troubleshooting the BGP sessions. So these are the commands that we need to use. And once we've done these configurations, we can go ahead and verify the BGP status. So let me start with R3. So I log into R3. On R3, we already have IBGP sessions, so we only need to configure the EBGP sessions. I'll go to R4. So on R4, I'll run these commands. If you do info, you will see the commands in detail. So you see that we have a group IBGP. We also have a group EBGP. And then on R5, we have a session to R8. So I'll copy this command. Again, always remember that you need to enable BGP using the no shutdown command. If you do info, you see that we have two groups, IBGP and EBGP. Next, we need to configure R6, which has two sessions. On R6, I configure the parameters for EBGP. So R6, we don't have any IBGP. So you see that we only have group EBGP towards R3 and also group EBGP towards R7. For these, I need to configure R7. So R7 has two sessions. I'll run the commands. You do info just to verify the configuration that we have in place. Finally, we need to do R8. So on R8, we run the commands. Show router interface to verify the interfaces that we have. Then info, you will be able to see the BGP configurations. So once we've done these BGP configurations, we can now go ahead and run the verification command. For example, on R3, I can show router BGP summary. You will see that we have 4 peering sessions. We have 2 IBGP sessions in a 65,000. We have a peering to R4 in a 65002. We also have a peering to R6 in a 65001. You can specify the group, show BGP summary, show router, BGP summary. Let me see whether I have the group. I use the IBGP. You see that we have this peering session. You can also filter based on the EBGP, and you should be able to see the BGP session within that group. Let me recall this command. If I do info, you will see that we have EBGP to 001 and EBGP to S005. So if I show router BGP summary again, you will see that we have the peering session between these different nodes. This is the uptime, the number of routes sent and received, the family, it's IPv4, the address family. You have the AS, the remote AS numbers, you have the description. So again, it's always a good practice to give it a meaningful description. It will help you when you are doing the troubleshooting. You can also verify the status on the other devices. We know that we have a peering session from R4 to R3. Can show BGPs, show router BGP summary. You will see that we have these two peering sessions. One is IPGP, another one is EBGP. On R5, we expect a session to R8, show router BGP summary. You see that we have this peering session towards R8. On R8, we also expect to see the same, show router BGP summary. You see that we have two peering sessions, one to R5 and another one to R7. So this is how you establish EBGP peering sessions. And we've already demonstrated to you how to verify the IBGP peering sessions. So now, after all these configurations for IBGP and EBGP, we can now go ahead and start demonstrating to you how to implement some advanced BGP features. How do you implement route reflection, for example? How do you advertise routes? If I were to check show router BGP routes, you see that we don't have any routes. Show route table protocol BGP, we also don't have any routes. So we now need to import some routes to BGP so that we can now use this routing information and apply some operations on them. For example, we can do AS path prepend, we can change the local preference, we can change the MED, all those operations, all those BGP attributes that we can play around. That is the goal of this training session. So I hope this is clear. I hope you've understood how to implement EBGP sessions on Nokia routing devices. I hope you understand the commands and the step-by-step implementation so that you can also go ahead and do the implementation on your own lab. It's always good to practice. I hope when you are watching this video, you are also doing the similar implementation. You are also running the commands on your end. By just watching the video, you may not learn much, but if you do the troubleshooting, remember my commands have already been prepared. From your end, you should also be able to prepare the commands, not just copy pasting everything. It will help you to understand the pain points. It will help you to understand how to troubleshoot the setups. So thank you so much for watching this session. I hope you've enjoyed it. Just remember to subscribe to this channel, also to turn on the notification so that you will be receiving notifications whenever we publish new videos on this platform. And I hope to see you in the next episode. Bye.